Okay, moving on to the second lesson for our last unit here, linear regression. Okay, so regression is an analytic technique for determining the relationship between a dependent variable and an independent variable. Regression helps to determine an equation which can be used to help make predictions. Okay, so this is all about determining relationship between two variables. So, like usual, the x-axis will have our independent variable, y-axis will have our dependent variable, and today we're going to be looking at how we can determine an equation for the line of best fit to show that relationship and basically make predictions when needed. Okay, so we'll get into that in a second. What we have here next is the least squares formula. Basically, what we're doing here is to figure out our equation for a line of best fit. We see the equation of a line here. Basically, what we're used to from grade 9 is y equals, normally we're saying mx plus b, right? Here it's ax plus b, but exact same idea. And this is still the slope, your a value, and the b value is still your y-intercept. Difference being here, we're going to have to use these formulas here. So this formula here to figure out the a value, and then you see the formula for your b value. Okay, so what we're doing here in terms of the least squares formula is coming up with the equation of a line of best fit so that that line of best fit minimizes the distance. The equation minimizes the distance between each data point and the actual line of best fit. So basically what we want is our data points to be as close as possible to the line of best fit to show, or that's what would show a strong relationship between our two variables. Okay, so how do we figure out, again, a and b? So here you see the formula for a. It looks like it may be really complicated, but it's something that if you follow step by step, it's not too bad. And we'll see examples of this shortly, where we just have a table and we figure out each of these sums. So remember this, what looks like an E sigma. This means the sum of all of your x's multiplied by y. This is sum of x's, obviously, sum of y's, sum of all your x squareds, and then this is your sum, the sum of all your x's. Once you get that sum, then you square it, right? Because the squared is outside the bracket. And then to solve for b, it's your y bar, right? So the mean of your y values minus a times the mean of your x values. Okay, so and n is, sorry, I missed out the n here. N is the number of data points that you have. Okay, so let's scroll down here and see an example. Okay, so the following table shows data for the full-time employees of a small company. Okay, so you have your independent variable is your age, and then the annual income would be on your y-axis, right? Your dependent variable. Use a scatter plot to classify the correlation between age and income. So if you do a scatter plot, literally just plot your points 33, 33, 25, 31, 19, 18, all the way down. You can see just by looking at this, we have our points are going up and to the right, and they're clustered close together. So we can say because they're going up and to the right, we have a positive relationship, and because they're clustered pretty close together like that, we can say it's a strong relationship. Okay, so graphically looking at that, we're just kind of like we're eyeballing it and saying we have a strong positive relationship. How else could we define the relationship and prove that it's actually a strong positive? We can come up with our line of best fit. Okay, and this is what we're going to do here. So the same data we have in the first two columns, and all we're doing in the remaining columns is figuring out the different pieces of information we need to plug into our formula. So we need to figure out x times y and add those all together, the sum of all the x, the sum of all the y's, get all your x squareds, add them all together, and then sum of all your x's, square them. Okay, so based on all of that, that's where this table is coming from, and you can see here we needed x squared, right? So we're squaring all the x's, so 33 squared, 1089. 25 squared, 625, so on and so forth. Add that entire column up, it gives us 11,712. The other thing we needed, which we don't have, is x times y. So you can see x times y, 33 times 33, 1089, 25 times 31, 775. And that's done all the way down here till 29 times 35, which is 1015. And for our formula, we need the sum of all of these. So we add this whole column together, and we get 13,221. Over here, sum of all the x's, 292. Sum of all the y's, 329. So basically, by doing this table here, we have every piece of, or every variable, if you want to look at it that way, or every piece of information we need to solve our a value. Sorry, the last thing I forgot again was the n. And how many data points do we have? Well, we can see 1, 2, 3, 4, 5, 6, 7, 8. So our n value is 8. Okay, so at this point, all we're doing is plugging in our numbers into the formula and letting our calculator do the work. So n is 8. The sum of x times y, 13,221. The sum of x, 292. Sum of all your y's, 329. The sum of all your x squareds, 11,712. And then take the sum of all your x's, 292, and then square that. Okay, so all of these numbers are coming from our table above. Now you just let your calculator do the work, and we figure out that our a value, or our slope, is 1.15. Once we have our a value, we can solve for b. But before we do that, and you can see in red here, we have to solve for x bar and y bar. Okay, so 292 divided by 8 gives us x bar, 36.5. 329 divided by 8 gives us y bar, 41.12. Okay. Plug those numbers in. There's your y bar, there's your a, there's your x bar, and there's your y-intercept. Okay, so the equation for our line of best fit then is y equals our a value, 1.15x, minus 0.85, which is our b value, okay, or our y-intercept. Okay, so there's our line of best fit. What can we do with that line of best fit? As I had mentioned earlier, we can make some predictions. So predict the income for a new employee who is 21 and an employee retiring at 65. Okay, so we have a set of data here, but we don't know the exact value for somebody who's 21 because we don't have a 21-year-old here, and then also we don't have a 65-year-old here. So we can't look at our table for that value or those values, but what we can do is now use our line of best fit and predict what a 21-year-old employee would make. So 21, the age is our independent or our x value, right? So all we do is simply plug in 21 into the equation of our line of best fit, and it tells us that we can predict then employee at 21 years old will make $23,300 a year. Same thing for the 65-year-old employee. We plug in 65 there for x, and we can tell then, or we can predict that 65-year-old will make $73,900 per year. There's two other, I guess, definitions here, interpolation and extrapolation. So interpolation is when we are estimating between our data points. So a 21-year-old employee, we can see again from our data range is 19 up to 54. So 21 fits between or in that range. So then we call that interpolation. 65 is outside of that range. So we call that extrapolation. That's all it is. Okay, so you can do this with any data that you're given. If you're ever estimating a point that falls within your data range, interpolation, and if you're ever estimating a point that falls outside of your data range, it's called extrapolation. Okay. Last bit here, remember your correlation coefficient, the R value, right? That's what tells us how strong or weak our relation is between the two variables. If the correlation coefficient, or if the relationship between the two variables is weak, your predictions based on your line of best fit may not be accurate, right? If your points are scattered far away, or they're not clustered around the line of best fit, then logically, then your predictions won't be as accurate. If your R value is strong, meaning all of your data points are clustered close to the line of best fit, then the predictions based on that equation from the line of best fit will be very close to the true value. Okay, so that's it then for regression. So just basically to recap, today's lesson mainly about coming up with the equation of the line of best fit and then using that line of best fit to come up with predictions. Okay, so and we'll leave it off right here. Again, just a quick recap. Figure out your A value is right there, and then figure out your B value is right there. Okay, so we'll stop there then.